Hello, my name is Aysha Bibi, and this is my presentation on the electromagnetic spectrum. So I'm going to go through explaining what the electromagnetic spectrum is, its characteristics, and its key importance. Yeah. So the electromagnetic spectrum encompasses all forms of electromagnetic radiation, from radio waves to gamma rays, and EM waves are defined by wavelength, frequency, and energy. Electromagnetic waves include non-ionizing and ionizing types. Its key importance is understanding how these waves enable advancements in fields from communication to medicine and astronomy. As you see in figure 1, there's an image of what the electromagnetic spectrum looks like, and the different types of radiation includes radio waves, microwaves, infrared, visible light, X-ray stocks, and X-rays, sorry. And then here there's also another image, in figure 2. It continues on, image of the electromagnetic spectrum. If we continue on, so we're now going to understand principles and properties of electromagnetic waves. So waves have properties: frequency, wavelength, and speed determine energy levels and applications of electromagnetic waves. An equation that links all these characteristics is the wave equation: speed plus frequency times wavelength. And there's different types of waves. There are 7 types of EM waves. Includes radio waves, microwave, infrared and visible light, ultraviolet, X-ray and gamma rays, each with unique uses. One way to remember the electromagnetic spectrum is red man in van using X-ray gun. So the first letter of each represents a wave. Here in figure 3 is a picture of radio frequencies of the electromagnetic spectrum, as you can see. And now if we go on to properties of microwaves and infrared radiation, they're useful for applications in heating and thermal imaging. An example is microwaves, microwave heating. So the microwaves cause water molecules to vibrate, heating food through dielectric heating. And another example is thermal imaging, where infrared cameras detect heat emitted by objects, and it's useful in night vision and diagnostics. So so the frequency range is, microwaves have a frequency of about 1 millimeter to 1 meter, and infrared 700 nanometer to 1 millimeter. Here in figure 4 there's a picture of microwaves inside a microwave. Yeah, this is a diagram and demonstration of microwaves inside a microwave. Then if we continue on, we're looking at X-rays in medical applications, uses and its hazards. They're used in diagnostic imaging and radiation safety. X-rays are widely used for diagnosing fractures, detecting tumors, and conducting chest imaging. They are also used for CT scans. Computer tomography provides 3D imaging, revealing detailed cross-sections of internal organs. One disadvantage of X-ray is its radiation hazards. X-rays are ionizing, posing risks of cellular damage and cancer, and so safety protocols are essential. Here you see in figure 5 a projection of X-ray imaging here, And then if you go on to figure 6, it's a diagram of X-ray production, which is here. The next topic is visible and UV light in crime scene investigation. So visible light is used for general photography and documentation of crime scene. So UV light highlights biological fluids, fingerprints, and concealed stains due to fluorescence. Furthermore, it is used for enhanced evidence detection. UV allows contrast enhancement on surfaces, revealing difficult to see evidence. And if you look at figure 7, there's a fingerprint here. This is figure 7, and this is an image of a fingerprint. Then also in figure 8, this is a crime scene where the crime technician examines rings from a crime scene with ultraviolet light in the laboratory here. Biohazards of ultraviolet and infrared radiation. So looking at the health risks in forensic investigation, UV light can cause skin burns, DNA damage, and increase cancer risks and cancer risk upon prolonged exposure. And infrared radiation, prolonged infrared exposure can lead to thermal injury and vision risks, especially without proper protection. So the safety protocols are very necessary when exposed to these types of radiations, and using things like protective gear, exposure limits, and filtered light